All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and we did just finish up our malaria precision, recall, and accuracy module. Let's have a look at what we went over today. Now, yesterday, if you recall, the last thing we went over was the AUC, or the area under the curve, and we're going to pick up where we left off. And so, in general, if we have two models and then we want to compare them, then we will use the area under the curve since it shows us how much freedom we have in playing around with the thresholds. Now we will get back to the code so we can see how we're doing to implement so we can see how we're going to implement these new matrices or these new metrics we've just talked about. We will do this by importing them to our program from the correct.metrics. After the accuracy, we will import the false negatives, false positive, true negatives, true positives, precision, recall, and finally AUC. I'll show you really quickly where we imported those over to our code. So you can see we're actually running that live here. You can see the TID, binary accuracy, root mean squared error, false negatives, false positives, true positives, true positives, precision recall, and AUC. So that's where we imported everything over from the correct.metrics. So we have that imported over now so we can actually implement it in our code and we can make use of it. So let's get back to the reading. Hold on, I didn't go down far enough. Okay. And after the accuracy, we'll import the false negative. Okay, we did that part already. And since we're dealing with the binary classification problem, we'll add the binary accuracy like I showed you. Now, next we will define the metrics list. Inside our metrics list, we will pass all of the imports as we just mentioned, including the AUC. So I'll show you that once I'm done reading. We will do this by setting metrics equal to metrics on line 128. And above our Lynette model.compile, we will define metrics as such. See line 125, I'll show you that. This is how it's going to look on line 125. We have metrics equals a list, and our list is going to have the true positive, name TP, false positive, name FP, true negative, name TN, false negatives, name FN, binary accuracy, name BA, precision, name precision, recall, name recall, AUC, name AUC. Let me fix this because that's supposed to be equals AUC. And let me put the bracket there. So that's that there. And then now let's compile and feed our model. I'm not going to do that obviously because we're going to do it overnight. You know, we have the issue with the GPU time constraint. So we're going to do that overnight and then have it ready for you tomorrow. But yeah, that's just the stuff we're going to take. So now we're going to compile and feed our model. We should see that we are training. As training, we will have all of the items for our matrix list displayed and accounted for. So when training, we're going to have rates for all of these new items passed in the list. That's going to be accounted for while we're training. So you'll see values for those. And now we'll go ahead and evaluate our model by using the net custom model.evaluate method, see line 138. And we'll be using the test data to evaluate our model. And we can set up the process like this. Note this will go above the evaluate method, see lines 134 and 136. And we're going to set that up like this. We're going to have the test data equals test data, test data set equals test data set dot batch one, and then we have test data set. Now we should successfully have evaluated our model after we run everything successfully. So let me show you everything that we have to do up here. So you can see here, line 128 is where we're going to have our. Let's go to line 125 first. You see our metrics equals metrics list. See the true positives name 2P, false positive name FP, so on and so forth, like I showed you below. This is how we're going to compile it. Lynette custom model.compile. You're going to see here metrics equals metrics. So the metrics is going to equal to this list here. History is going to be the same. We didn't do anything with that. And then we're going to have our test data set equals test data set dot batch one, our test data set, and then we're going to have our Lynette custom model dot evaluate test data set. Now we're going to run all of that overnight, and I should have no problems running it overnight, and then we should have some results for you tomorrow. But we did finish the malaria precision recall accuracy module, and we started a new one. We didn't start it. I just got everything queued up to start tomorrow. This is going to be the confusion matrix. So in this section, we will be going over the confusion matrix in more detail. Up until now, we have been using everything from the binary accuracy up until the AUC. Now, what if we plotted out the confusion matrix and also the ROC plot? I'm pretty sure we're going to do a lot of plotting in this next module coming up. So yeah, I'm looking forward to doing that. But of course, I will keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.